have some more to share with you regarding significant figures. Why do we use significant figures? Why are they so important? And why am I making such a big deal out of this thing that seems so silly? It's because there are some things that don't make sense in chemistry if you don't use significant figures. I mean, there are measurements, all measurements actually, not just some, but all measurements in chemistry make sense only if you're using significant figures. And here's what I mean. Let's say you have a big bucket, and the bucket has liter markings on them. So that's 1 liter. That's 2 liters. That's a 1 there. That's 3 liters. And it's 4 liters. This is a very big bucket. It's like one of those buckets that you use for making bread, and the dough needs to rise, and so you put it in this bucket, and it has liter markings here to show you how much your dough rose. But anyways, let's say you fill this with some liquid, maybe a blue liquid, and the level is right there. So this is all full of liquid, right? What is the volume here? Yeah, if you did the previous homework quiz, then you would probably read this volume correctly as 2 point something liters. I would say perhaps maybe 2.9 liters. Okay, 3 liters would be wrong. 2 liters would be wrong. 2.5 liters would be wrong. 2.91 liters would be wrong. All of those would be wrong. But I already told you why in the previous homework assignment. So 2.8 liters would be right. 2.9 liters would be right. I'm not sure, but 2.7 liters might be right. It's kind of pushing it there though. But anyways, let's assume that your answer here is 2.9 liters. Okay, and then a fly comes here. A fly, right? And the fly poops into this water. The poop was so small that you didn't even see the poop. Okay, but the poop is matter. It has mass and it does take up space. So when the poop enters the water from the fly, it is not 2.9 liters anymore. It is 2.9 liters plus 0.0001 liters. Let's say this is the size of the poop, the fly poop, 0.0001 liters. Okay, so we have added a certain volume of stuff to the water. So what is the answer here? What is 2.9 liters plus 0.0001 liters? What is the new volume? Let me add those up together for you. The new volume is 2.9001 liters. Correct? Wrong! This is not a math class. This is not how you add measurements. The reason is 0.0001 liters has a very high precision. You see this number right here? It's in the, not the tenths place, not the hundredths place, thousandths place, it's in the 10,000ths place. The precision is very high. This number here, this is a tenths place. The precision is low compared to the other number. What I mean by precision in this sense is the number of decimal places, the number that the measurement goes out to. That's the precision. Your textbook uses the word precision also, but it gives you a different definition for that, which I will make a separate video for. But the most important definition is this one, which is not mentioned in your textbook, and that is the number of decimal places that your measurement is going out to. All right, so what does it mean that the precisions are different here? It means the following. This was 2.9 liters, except this 9 was the uncertain digit. So we actually don't know if this was 2.8 or 2.9. It could have been either of those. And in fact, here's what we really didn't know. We really don't know, was this 2.90, 2.91, 2.92, 2.93? Do you see where I'm going here? We don't know if any of these are true. This instrument cannot give you that information. So what does that mean? When you add 2.9 plus 0.0001, you don't know if it's 2.9101 because maybe this 2.9 really meant 2.91. You don't know if it's 2.92 401 because maybe this 2.9 really meant 2.92. You don't know if it's 2.9301 because maybe this 2.9 really meant 2.93. You don't know if this is 2.9401 because maybe this 2.9 was really 2.94. You don't know any of the you just don't know. Okay? So if you don't know, then you can't be saying that the answer here is 2.90001. You can't say that because you don't even know what this was. Then what is the answer? Let me tell you what the answer is. 2.9 plus 0.0001 in liters. If you add these together, the answer is 2.9. This is how you do it. You do the math, of course, and then you round the answer off to the least number of decimal places in the data. So here's a data. This is a measurement. This is a measurement. They are data. This guy is to the 10th place. This guy is to the 10,000th place. You need to round your answer off to the 10th place. In other words, you need to draw a little imaginary line down here that that goes to the right of the last digit of the least precise measurement. And then you need to round the answer here off right at that line. So this is 2.9. The answer here is, this is an arrow, by the way. Okay, this is an arrow, by the way. The answer here is 2.9 liters. That's the answer. So I have a baby, she's 3 years old. If you stand her up here, right, and then she spits into this container, is the water level going to rise? These are liters, folks. You know, like a 2-liter bottle of soda? That would fill up right here. If my little kid spits in here, that's gonna add like, okay, this was 2.9 liters, and my kid spits in there. That's gonna add like maybe not 0.05, that's a little much. Maybe she spits a little bit in there, and she adds 0.02 liters. Okay? What's the answer here? The correct answer is 2.9 liters. It doesn't change the volume. Why? Because you're not even sure what the volume was to begin with. 2.9 liters, you weren't sure about, you don't know the next digit after the 9. And so to 2.9 liters, it stays. What if she spits in here a lot? No. What if she takes some water from the sink, she rinses her mouth out, like she's brushing her teeth, and then she spits all that water back in there. Her mouth is very small, let's assume. And so when I say all that water, let's say it's only uh, two, it's only 0.5 liters, right? So maybe you see the water level rise a tiny, tiny bit. And so this is now 2.95 liters, but you don't know about that last digit, so you need to round it off right there. 2.95 rounded to the nearest tenth is 2. We need to round this number off. The next number is 5. So this number gets rounded up, so that would be a 10, but it's not 2.10. You can't do that. You have to carry the 1 here. So it's actually, arrow, it's actually 3.0 liters. So after my kid rinses her mouth and spits in there, that's 3.0, 3.0 liters. And then you would see the water level rise, and it would stay right there. Okay? Water level would stay right there. Okay, actually, 0.05 liters is kind of a lot. But let's just assume she has a big mouth. So that'll be 3.0 liters. I just did rounding here, and I'm not sure if you remember. Yeah, I've had students in Chem 65 who forgot how to round, so let me just review that really fast. If you know how to round, you can just stop watching the video right now, but if you don't know how to round, let me give you this little rule here. I'm going to round this number to the hundreds place. To round this number to the hundreds place, you look at the next digit. If it's 5 and above, you give this number a shove. That's how you remember. 5 and above, give it a shove. So this digit right here is 5 and above. It's 7, which is above 5. And so this number gets a shove. The rounded number is 700. Okay? Let me take this same number here and round it to the nearest 10. 5 and above, give it a shove. But this is not 5 and above. And so I leave this by itself. It's just 670. I leave it alone. This is not 5 and above. So 4 and below, keep it down low. 4 and below, keep the 7 where it is. All right? That's how you round. Okay, that's it. Please do the homework.